Welcome everyone to one more speaker series. My name is Franziska Posler. I'm a postdoctoral researcher at the Institute for Ethics in AI at the Technical University of Munich. And with its speaker series, the TUM Institute for Ethics in AI invites experts from all over the world to talk about ethics, psychology, and governance of AI. And these events serve as an important platform for sharing new research and exchanging knowledge. Since our launch, we were already able to run 42 speaker series events with distinguished guests from all over the world. Today, we have Professor Eyal Aharoni here with the topic on Pandora's bots, studies of AI moral advice and their implications for human decision making. And we have the pleasure to invite him and have him here today. Professor Eyal Aharoni is an associate professor of neuroscience, philosophy, and psychology at Georgia State University. Prior to his current appointment, he served as a research associate for the RAND Corporation. Aharoni completed a postdoctoral fellowship with appointments at the MINT Research Network for Neurodiagnostics Discovery and the University of New Mexico Psychology. He has also held research positions at the Research Center for Virtual Environments and Behavior and the Institute for Social, Behavioral, and Economic Research, where he studied human-computer social interaction and the perception of agency. Professor Aharoni earned a bachelor's degree in psychology and religious studies from the University of California, Santa Barbara, where he also earned his PhD in psychology. So we're very grateful of having you here. We will start with the presentation, and afterwards we will have the opportunity to hear all your questions and comments, and we will try to answer all of the questions, of course. So now I would like to invite Eyal Aharoni to the stage, and the floor is yours.
Thank you very much, Franziska. Thanks to all of you. It was a matter of luck, I think, that I'm able to be here with you. It just so happened I was going to be in Munich when I received this invitation for an interview for the project that you're working on here, which is a very exciting project. And I'm so glad that it gave me an opportunity to come learn more about the center and the work you're doing here and to share some of my own work. This is a relatively new line of research for me. And so, again, I'm eager to hear your feedback on my studies of AI moral advice and their implications for human decision making. My starting point is that as someone who studies moral reasoning, we know that moral reasoning is often regarded publicly as sort of one of the most distinctive and sophisticated of human competencies. And so a lot of people are asking whether large language models might challenge this tenet. They seem to outperform and even enhance sometimes human reasoning in various ways. And yet they have a lot of known problems, which I'm sure most of you are well aware. The systems being largely opaque to interpretation. They're often riddled with biases, not just demographic biases, but oversensitivity to contexts that we're often unaware of. Virulence, which is my term for if something goes wrong in an AI system that's already been released at scale, then that can have cascading effects very quickly. If there's a bug in a system that's shared by a million computers, you get sometimes catastrophic failures that wouldn't occur inside the mind of a human decision maker. Because of the boundaries of our skulls. So there's those kinds of problems. And of course, AIs are programmed to always respond, no matter whether they have a good answer. And so this has led some, like Harry Frankfurt, to describe these kinds of communications as bullshit generation. The technical meaning being that they have no regard for the truth or falsehood of the output that they're producing. There's also been some analogies drawn to the construct of psychopathy, a topic that I've studied in prisons with inmates to assess who's high in psychopathic traits, because these are the individuals who tend to lack the emotional and inhibitory responses that would normally keep most of us in check and out of prison. And so there's been some loose analogies drawn to whether, we can understand an AI as being sort of like a psychopath in the sense that it lacks many of the emotional checks and balances that we have when we engage in human reasoning. Now, there's two broad questions that arise from these observations. One is the metaphysical question: do LLMs actually have moral intelligence? And as a psychologist, I consider that the hard problem. That's not a problem I'm going to try to pursue in this project, but something that we can certainly discuss afterwards. I'm going to be asking what I view as the comparatively easier problem: do ordinary people perceive LLMs as having moral intelligence? Now, I'm guessing most of you are already familiar with the Turing test, but just to refresh our memories quickly, this is a classic test that Alan Turing developed, the generic form of which is, in order to test human perceptions of machine intelligence, you have human, C, the interrogator, trying to communicate with two entities that are masked behind this wall here. They can only communicate in this version by text. The interrogator can ask any questions they want, and their objective is to try to guess which one is the human, which one is the AI computer. Often considered sort of the gold standard of assessing machine intelligence at one point in time. Now there are debates about whether that's still the case or whether there are flaws with this method. But it still served as a useful starting point for our project on the moral Turing test. So the moral Turing test was proposed by Colin Allen and colleagues. Allen's at UC Santa Barbara as well. And they proposed, if you want to assess machine moral intelligence, you can use essentially the same method, but with moral content, moral dialogue. I would refer to this as the explicit moral Turing test, because you know that one of the two entities is a computer, and so that already sort of gives you a head start. On the other hand, that method is also susceptible to different kinds of demand characteristics, like the tendency for person C to import their own prejudices and preconceptions of what they think an AI computer might communicate like, and so their own preconceptions might bias their responses. So Allen and colleagues came up with another version of the moral Turing test called the comparative moral Turing test, where you're not informed that either entity might be an AI machine. You're left to assume that you're communicating with two people, and your only job is to judge the quality of their responses. So that means we need to come up with different ways of assessing the quality of the commentary and asking participants to rate that quality on several dimensions. So that's the approach that we took with our test, starting with the comparative moral Turing test, followed by the explicit test. So in the first phase, they didn't know that one of the entities was a computer, and in the second phase, we revealed that and asked them to make a guess based on the moral commentary that we elicited from it in advance. So before conducting these studies, we needed to elicit that moral commentary from a human sample and in this case, GPT-4. We started by selecting 10 scenarios which described brief transgressions that had been pre-validated in our previous research with large samples of US adults including also prisoners who were high and low in psychopathy, because at the time we were interested in how well psychopaths could tell the difference between what are known to be moral transgressions versus conventional ones. A conventional transgression is something that is considered wrong by mere convention. And I'll give you an example of what I mean by that in a moment. Whereas a moral wrong is what we would consider a typical moral violation, like harming somebody directly and intentionally. So we administered these to GPT-4 and to 68 undergraduates to try to identify, screen for what we thought to be some of the best responses from the undergrad sample, asking them to please explain in a few sentences why this act is or is not wrong for each of those 10 acts. By the way, if you have any clarification questions along the way, feel free to raise a hand, but we can try to save the meaty discussion questions for the end. So here's an example of conventional transgression. So at his mother's funeral, a man wears a t-shirt and shorts, although everyone else is in formal wear. And so we get our response from the LLM, GPT-4, and our response from, this is one of the better responses from the humans as judged by our blind raters. You can take a moment if you like to glance at them. We can always come back to the details later. Okay. And then we had our pairs of moral responses for each item. One from the human that was rated highly and one from GPT-4. And we administered those to our new sample of about 300 US adults on the Prolific platform. And that sample was matched to the US census distribution on age, gender, and ethnicity, so we could ensure that it's relatively representative of the broader US population. We had some follow-up questions that I could share with you at the end if you like, manipulation checks. And we also looked at how well the GPT-4 actually identified those pre-coded moral and conventional transgressions, and it performed as well as our human samples have in the past. So that's sort of a pre-validation. Our predictions were, number one, that participants, this is now for the comparative task, participants would rate the computer-generated moral evaluations as better in quality than the human-generated evaluations, even though they didn't know that a computer was involved. And these were the dimensions on which we asked them to rate. So intelligence, how intelligent, how rational, how much do you agree with the response, how trustworthy is the speaker, how virtuous, which one's a better person, which one's less biased, which one's less emotional, which one's more compassionate. So a variety of items, some of which were reverse coded. Hypothesis 2 was that participants in the explicit moral Turing test, they would fail to correctly distinguish between the sources of the human and computer-generated moral evaluations, resulting in a 50-50 kind of null hypothesis. These predictions were pre-registered on OSF. And here's the results of the comparative moral Turing test. And a lot of numbers here, but the important thing is first to note that for each of these dimensions, the more negative the number means greater preference for the computer on a scale that goes all the way up to -10 and then +10 with the human on the other side. So you can see almost all of these are negative and significant, indicating that participants rated the masked computer responses as more intelligent, more rational, they agreed with it more, it's more trustworthy, and so on. The only dimensions in which we didn't get that effect was neither one was rated as more biased, more emotional, or more compassionate, although I should have mentioned that the last two items, emotional and compassionate, we didn't have strong hypotheses about those two dimensions. So this explains why individually or in aggregate, we get this significant effect favoring the computer. So far, so good? All right, so that first hypothesis was confirmed. After that, we asked, before we spilled the beans that there was a computer involved, we asked them to guess what they thought was the source of these statements. And very few people were suspicious that any of the responses were generated by a computer. So 97% believed they were human generated. Oh, I should mention this graph was not in our publication. We developed it afterwards. But if you were interested in seeing those dimensions broken down by the individual item, the important point on this graph is that for almost every item, there's longer blue bars than red bars, indicating more preference for the computer. So then we spilled the beans. We said, all right, one of these two comments in each pair was actually generated by an artificially intelligent computer. And we want you to go back to the same pairs of items and guess which is which. And here you can see, well, overall, turned out that about 80% of participants made the correct identification more than half the time. So that's contrary to our hypothesis. And if you look at the individual items, C for conventional, M for moral, for all these items, except for the last one, they were able to, on average, correctly detect which one was a computer. This surprised us, right? But in hindsight, when you look at the response, when you compare this to the response that we got on the comparative moral Turing test, where they rated it higher in quality, it leads us to interpret this failure as rejecting the hypothesis on a technicality. That maybe what's going on here is that the computer responded too well. Because they rated it as so high in quality, perhaps it's the case that they were able to detect which one is a computer, not because it was excuse me, lower in quality as Alan Turing might have worried, but because it's higher in quality. So, so that's one possibility. Before I offer another, let me mention what we're not claiming here, which is, again, the study is not showing that LLMs are, in fact, morally intelligent, or even that the MTT is a good example of an IQ test for computers. Excuse me. Or that humans regard LLM evaluations as superior in general. We only know that they regarded them, that our participants regarded them as superior along the dimensions that we tested. So what we conclude from this study is that participants perceived the AI's moral responses as superior only along the dimensions we tested, that the AI's perceived expertise may have given its identity away, and that the LLM could distinguish between moral and conventional wrongs, but of course, so can criminal psychopaths, and so that doesn't necessarily tell us too much about their moral sophistication. There are, well, let me mention that one in a second. What we concluded in the sort of our implications in the study that we reported in scientific reports was that if people regard these AIs as more virtuous and more trustworthy, as they did in our study, then the worry is that they might uncritically accept and act upon such questionable advice. Now, future directions and limitations. One other interpretation of our second result, where we failed to affirm our hypothesis, was that they were able to tell the difference between human and computer based on superficial, maybe syntactic differences in the language. When you look at the Those of you who are more exposed to this kind of technology and think about this a lot are probably familiar with some of these idiosyncrasies that might give the identity of the LLM away. It tends to speak more formally. And we tried to, I should have mentioned earlier, we tried to adjust for some and match some of those differences in advance by controlling the temperature on the LLM and by doing some very minimal sort of controls to make sure, for example, that the human responses didn't contain grammatical errors and things like that. So we did some minimal matching, but there still could have been some syntactic differences that we didn't account for. So in a future study, we'd like to try to control for those and see whether we still get the same effect. It would also be interesting to take an approach that is perhaps more faithful to Turing's original design, which would include doing more to actually coach the AI to imitate a human. We chose not to take that approach because we wanted to know how well people performed relative to sort of the status quo, the GPT's status quo or default voice, which is sort of the voice that most lay people will be interacting with it in. But in a future study, we'd like to do more to coach the AI to imitate a human. And we could also test more ecologically realistic interactions that are, for example, interactive rather than this sort of one-way static method that we chose for our first study. Of course, designing an interactive study where the human and AI can dialogue presents challenges for experimental control, but presumably with multiple methods showing the same type of result, we could start to answer these questions more rigorously. So those are some examples of our future directions, and at this point I'd like to shift to our next study for which we don't have data yet, but which I would like to hear your feedback. And before I move forward on that, maybe I can stop to see if there are any questions on this project. I guess, again, we could save the bigger ones for the very end, but if you have...
You said about the catastrophic events which could lead to something. We have seen that, I mean, I'm not a great, I would say, I've known AI a bit and I'm interested in, I use ChatGPT, but I'm scared that when there's always this, what I saw that when WhatsApp was introduced, there were messages going on and fake messages were shown and people acted on that. Now, that was on a smaller scale, right? On AI, if something of that thing happens in echo chambers where you have thousands, if not millions, of people like-minded, say, for example, they say, oh, end of the world is coming, we should all commit mass suicide. I mean, the time by which you take the action to stop that, because if it goes there, I mean, it's unimaginable. Don't you think that AI is dangerous? I mean, this kind of thought process, what do you have as a means to stop that, to counter it? This is for me, it's a real, dilemma. Should I use it? Should I listen to it?
Well, I think you captured that worry better than I could, and I sympathize with it. I share your concerns, and I think a lot of the people in this room probably have opinions about that and how we would respond to it. So it's also a question that's relevant, I think, to the next project. So do you mind if we can bring this up again at the end, because
after I forget it otherwise.
it's broadly relevant.
I've actually also one question relating to the project that you just shared. Did you give or did you ask also the participants to answer in an open-ended questions reasons why they were able to tell that it was computer-generated responses?
Yes, we did. We collected this free response data. Many of the participants, I can tell you sort of unsystematically, many of the participants did indicate that it had a different tone of voice. Mm-hmm. Few of them said because it was a better response. They were looking for other explanations. It's unclear how much weight to put in the free response data, just because I have my own kind of concerns about how well we can objectively characterize those responses based on strong assumptions that we have to make as qualitative raters. But yeah, that the kind of syntax and tone kinds of responses were among the highly rated responses there. Yeah. Great. So some of these questions that you have, I hope will tie into the next project as well. And let's start with the following. So in doing my research for this project, I learned that 1/4 of emergency cases in the US are believed to be under triaged. So when someone experiences a health emergency, they're usually, when they're triaged, they're classified like high, medium, low risk. And I'm going to get a lot of the medical terminology wrong, by the way, because again, I'm new to this subject. But it turns out that 7 million of them per year may be under triage, meaning they're classified as lower risk than they actually should have been, therefore not receiving the emergency care that they should. Emergency triage is based on formalized protocols that humans typically carry out. Humans are known to be error-prone and not especially good at deductive and algorithmic types of reasoning. So suppose that an AI is developed that can outperform first responders in emergency triage decision-making. Well, it presents to us a kind of a new dilemma. So you're familiar with the trolley dilemmas, but this is a really new kind of dilemma. Option A, we outsource the decision-making to the AI. The benefit is that it could probably triage faster and more accurately if trained properly. But as a consequence, could reduce human performance, because we're not making the big decisions, and we could potentially lose attention and vigilance and skillfulness. And it could also risk these occasional catastrophes that we mentioned that AIs could be susceptible to at a large scale. Option 2, exclude the AI, do the status quo, maximize human performance as we have been trying to do, limit those occasional catastrophes, but ultimately accept a higher error rate of the human error that we've been incurring all along here with these 7 million misses in the US. And so what do you do? Well, you might say maybe the AI will never quite get there. But actually, just a couple of weeks ago, OpenAI came out with a study that directly compared a triage-trained GPT model against 250 or so human physicians from around the world that had given their own independent ratings of what to do for all these different cases. And you can see how it performs. And there's some other conditions here that I won't talk about. The relevant condition is that it performs better than physicians on basically all dimensions that they tested. Thank you. And so, and this is not the only evidence. There's some other papers coming out showing similar effects that you might have come across. And this is not necessarily a problem with the technology, right? The technology is performing well. It's the humans that we have to worry about. And we know that humans are susceptible to certain kinds of problems like deference to automation. So this is not a new problem. And you're familiar probably with traveling in your car with GPS. And if you lose a Wi-Fi connection or your batteries die, then you're screwed. In many cases. I've lost, I think, my navigation abilities because I've become so dependent on the AI. And there's actually some studies I found that have demonstrated that people who use these kinds of tools do tend to show reduced spatial reasoning abilities. So we've known about these for a long time in human factors psychology, and it presents this sort of paradox that as AI performance increases, human performance will tend to decrease because we rely on it. Now, if we defer to an inferior AI assistant, that's an obvious problem for the quality of care that we might offer to medical patients. But even if the AI's judgment is superior on average to professional humans, it's still a problem because we'll tend to outsource our decision making potentially beyond its scope of training, or in cases where we have these kinds of problems like loss of signal. So the problem is that when the AI seems reliable, humans will tend to increase their risk exposure by offloading task demands and ceasing to monitor for errors. And one scholar in Germany, who some of you may know, Sebastian Krugel, has also found that to make matters worse, people tend to underestimate how much they're influenced by the AI. So this is sort of a dangerous combination of effects. And again, the technology is not the problem. It's the humans that we have to worry about. So how do we get human and AI to collaborate effectively without de-skilling and inattention, the kinds of psychological errors and biases that we've known about for a long time? So one context in which we can test this is medical triage training. This project started with my pointing my GPT camera to a triage training simulator online, one that's used commonly across the US. And I played dumb, which was very easy for me. And I said, here's a patient. What do I do? Tell me what to do next. One after the other. It proceeded to tell me exactly what I should do next. Now, I had no way to evaluate its accuracy, but I contacted Mark Cicero, who's an emergency physician who created this game at Yale University. And I said, what do you think of this? And he said, this is really interesting and something worth looking into. And so he agreed to join me on this project where our first step is to fine-tune an AI, probably a GPT model, to train it on standard triage protocols, or I should say to fine-tune it on standard triage protocols, and to test whether it can reduce, in this first case, nursing students' classification errors in triage on the game. And so at first pass, we're literally going to be pointing cameras so that we can capture both audio and visual performance on the game by the human, and the AI will actually coach the human nursing student through the game multiple times. And you can see across sessions what our predictions are. In the control group, you can see the curve where people who don't have, who are not receiving advice by the AI will probably tend to show gradual improvement over time. And our prediction is that those who are given exposure to the AI feedback starting after their initial practice trials will show improvement at a higher rate, so their performance will be relatively higher. And the big interesting question to me, psychological question, is what happens when, after trial 4, you pull the plug on the AI and you say, oh, we've had a system freeze, so you're going to have to complete the last trials, the last rounds of the game on your own. And the interesting question, I think, is whether their performance will go even lower than baseline because of that reliance that they've been building on outsourcing to the AI. So that's the design of the first study, and we now have some seed funding to carry this out. The second study that we hope to get funding for would be to manipulate the type of feedback and the nature and format of the feedback that is provided by the AI. So in addition to feedback versus control, we can look at subtler questions like active versus passive feedback. In other words, does the human respondent have to ask for the feedback in order to get it? Is the respondent expected, is the human user expected to generate their own answer before they ask the AI for its answer? Is the AI allowed to give an answer at all, or can they just give hints? So we can structure those collaborations to identify which formats are most conducive to long-term performance that is robust against robust to incidental problems like pulling the plug, and which formats are going to create those very problems. So what we hope to do with the results of this study is develop a set of not just general ethical recommendations, but also concrete practical recommendations, both for operational procedures in developing tools like this, but also policy manuals that will ensure that our best practices are implemented into the designs of these types of tools. So, for example, will we recommend routine manual training? One likely recommendation would be to encourage students to undergo manual training without the AI on a regular basis. To require trainees to render their own judgment before they're allowed to get the AI's recommendation. To prompt trainees to provide a justification for their initial decision to ensure that they're really processing their reasoning task deeply. For issues like overtrust in AI, we can present cases where what's known as fault injection, cases where the AI's advice is deliberately incorrect. They don't know that, and so it's a way of providing them with feedback after the exercise to kind of learn to be skeptical of the AI's advice, that it's not always reliable. And then finally, for the opposite problem, algorithmic aversion, sometimes we might want, maybe people will reject this technology for various reasons, even if it works well. And so there's some ways that we can try to respond to that, for example, by identifying the subjective features of the task. So what I mean by that is Sebastian Krugel's work that shows, ironically, that people are most averse to AI interactions when they perceive the AI to be making judgments for objective type decisions. And so like deductive type decisions. And I would have expected just the opposite, because the computers are known to be good at objective close-ended problems, and so you might think that we'd trust them more in those contexts. But he finds just the opposite. And so we can learn from that kind of research by showing them and framing the problem as a subjective type of problem that requires, advanced reasoning in order to get them to be more comfortable using tools that in fact do save lives. That's an assumption that we still need to test, though. So to develop these best practices and explore the broader ethical implications, on my team are two philosophers, Eddie Namias from Georgia State University and Colin Allen from UCSB, where we want to explore some questions that I think will interest you as well. What constitutes responsible collaborative design with AI? How accurate and reliable must it be for certain kinds of applications? How autonomous should it be? Should it be bias-free? That would be nice, but we know that with humans anyway, there's no such thing as a bias-free human, and a bias-free human might make really terrible decisions. So which biases do we want to rule out, and which ones do we want to retain? And how do we ensure that we can actually measure and track those biases and manipulate them? How transparent must it be? Again, it might not be full transparency might never be possible. I know people are working on this, but what is the sweet spot there? And some other questions, including ultimately who is responsible for harm caused by this kind of technology? And so I have just a couple of data points from my first study that I shared with you to speak to that question, because in our follow-up questions of the moral Turing test, we asked them things like, when chatbots share moral information, how strongly should that information be regulated, and to what extent should artificial systems be held responsible for the information they share? And people do respond affirmatively to both of these questions. They feel strongly that that these tools should be regulated, and interestingly, that the systems should be responsible for the information they share. Although, you know, I think that presents a puzzle for us and designers of the technology to interpret that and ensure that responsibility is going on actors that actually have some ability to control the accuracy of the technology. So I think I'm out of time. I'll stop there, and thank you very much for your time. So any questions? Yeah.
Thanks for your presentation. This is really interesting to me. I used to work in the health system and health policy, and I know it's popular in Europe as well as here, the idea of creating a learning health system where you're feeding data into the health system to improve practices and incorporating AI and stuff like that. I know it's becoming quite a thing. I guess my question is, do you think you're going to control for or incorporate resource limitations in the moral decision making? And
Computational resources?
not so much, more like, so I can give you an example. For instance, in the area that I used to work, we had a lot of remote hospitals, and the issue wasn't so much straightforward decision making, but it was things like, okay, well, there's only one machine left in this hospital. I have however many healthcare practitioners. I know the right thing to do, ideally, but I can't accommodate, you know, et cetera, et cetera. So this is really interesting to me because I know in the US there's also a different insurance system, and so the decision making there is quite different from Canada, for instance, where we can, you know, universal healthcare is a thing, but we don't have a lot of resources in some cases. Anyways, so
Right.
that's my question.
Thank you. Well received. Yes, and I understand that healthcare resources are a big issue, even in countries like the US, where there's a lot of money in healthcare that somehow doesn't always trickle down to the patient. So this is a problem, particularly in lower economic environments, including rural areas. And so this is precisely why I think research like this is needed, because I think there is built in a demand for improving AI, I should say, improving triage decision making so it can be done reliably and quickly and accurately. And that means when we have insufficient resources, we can still do it well, even in environments like rural areas that we normally wouldn't be able to reach. So the AI factor presents a potential opportunity to improve reach to these other populations and improve, as I said, accuracy overall. Now, what kinds of resources do we need to run AI? That's a whole other question, which is why I asked about computational resources, because we've all now heard that, you know, adding a question mark at the end of your query, you know, kills so-and-so many trees. I don't know the numbers or how well those have been vetted, but obviously it takes a tremendous amount of computational power that should be included in any ethical analysis that has to trade off between, in this case, you know, patients' welfare outcomes and health outcomes. versus what we're doing to the environment, which could ultimately also harm us in terms of healthcare. So, so I don't have like a clear answer to that question, but I hope that by doing these interdisciplinary studies where we're exploring both the potential benefits and risks of the technology, that we can eventually come to some recommendations about how to balance those trade-offs. Yeah.
Thank you for your very clear presentation. My question would be about, I'm a PhD student in the Alignia project, and I'll work with adolescents about their beliefs and attitudes towards LLM or AI agents. So about the last slide, that MTT study, and how did you generate the items, and what were the considerations and concerns, and how did you generate the items?
Yeah, so you're referring to
and
those
also
moral and conventional
Yeah.
transgressions?
And I may wonder about the psychometric properties, or it was just, I don't know, it was a scale or questionnaire.
Thank you, yeah. So we used, for context, there was another set of items that were popularized by Turiel, is a well-known psychological scientist, and later James Blair, who studies psychopathic personality in youth. And they developed scenarios which were really what we call playground scenarios. Bobby hit Billy in the face, you know, is this wrong, why or why not? Things like that. And in my lab in year 2011 or so, we weren't satisfied by using those stimuli for an adult population. We were working with, as I said, prisoners and non-prisoners, adults high and low in psychopathy. And so we came up with our own stimuli. We conducted a pilot test, a validation test on UC Santa Barbara undergraduates. I'm now going back to my memory from 2011, so you know, bear with me. But after that, we administered it to a large online sample of, I think, a few hundred people, representative of the US population, where they were rated on a variety of dimensions. For example, would this act still be considered wrong even if an authority figure said it's okay? So this is a classic criterion in moral psychology, that if Bobby hit Billy, I'm just using the previous example, but Bobby hit Billy in the face, but the teacher said that today it's okay to hit each other in the face. Does that make it okay? You know, even most young kids will understand that no, it's still not, because moral wrongs have a certain independence from authority figures, and they're resistant to that, those claims. So, whereas conventional wrongs do not. So we submitted our items to those kinds of questions, and only used the ones that performed well on reliability and accuracy. So there were several. I think we actually started with at least 40 items. So these were the 10 best performing ones. I'd have to go back if you want. I'll send you the paper if you want to see exactly how we analyzed. And you know, yeah. Okay. Yeah. Mm-hmm.
I just wanted to ask, because earlier you mentioned in AI decision support that there's the option of outsourcing to AI and also excluding AI entirely. And considering your papers primarily in pharma, or like primarily in the medical field, I would assume that, would you be using this for diagnosing? And if you are, because this is the EU, and in Germany especially, there's a lot of data protection laws, and yeah. How do you, without like collaborative efforts within the EU, maybe just in the US, how are you guys subverting that data protection when you're maybe using patients?
It's a great question. I think one of the items that I didn't mention on our list on the slide is about patient consent, which is already really tricky in the context of emergency care, where patients are not always able to consent. And so there's a body of literature that I think we can look into as a foundation for those kinds of decisions. I don't have a great answer to your question because it's sort of 2 steps ahead of where we are. If we show that the tool is effective, then yes, we need to kind of wrestle with these questions of first, what is the business application? Would diagnosis be included? Well, you know, my understanding, at least in the U.S., is that you know, emergency triage is really not meant to give a final diagnosis, and yet they need to act as diagnosticians to some extent in order to triage and provide care. So that means collecting data from the patients. Will the existing framework that's in place for, you know, when doctors use technology to provide diagnosis in these contexts, will those regulatory frameworks cover us or not? You know, is there something special about what AI is doing, especially if we're working with open AI, ironically, which, you know, isn't very open about how they use the data. And so presumably there would have to be special partnerships, you know, contracts with companies that assure, you know, HIPAA levels, you know, patient safety in terms of data privacy. I myself have concerns about companies that have made those kinds of claims and then violated them. So I'm not here to sort of say this is, you know, that we should all be using this technology, but rather to try to study it in advance of the likely scenario that it will come out so that we can answer these kinds of questions. So yeah, it's a bit of a dodge to say that I need to think about it more in conversations like this to sort of learn about what makes AI special. So what additional limitations will we need to place on it in those contexts? Yeah. And then back to your question, could you please remind me?
It's about, I mean, I think, I mean, please don't misunderstand me. I am always for technology. But in my life, I'm a bit older than most of the people here almost. I've seen that every technology has always had bad effects before it does, because humans are, you know, as you said, some have ethics, some don't have, some are, so the kind of, you know, when credit card was issued, people siphoned money, duplicating things and everything, you know, so every time. But those scales were limited in nature, you know, and with this AI, which as you said, is a worldwide implications. You have wars, you have certain, you know, people are on tender hooks, if I may say. There is a lot of divide in the US and in here and everywhere. So we are in a stage where something which is on a scale which is like, everyone says, oh, this is true, this has happened. And there will be consequences which there is no return back from. And given the technology, the stage at the infancy, do you really have the stopgaps, the possibility of stopping that in the next 5 to 10 years? Because this is a big, dangerous situation, I feel. Maybe I'm wrong. Maybe I'm too pessimistic. But I would like to know.
No, yeah, unfortunately, I share some of your pessimism. I think it remains to be seen what's going to happen, and that we need to be preparing for the worst case scenario. Your example of deep fakes, you know, has only gotten worse with, in just the past weeks, the release of these deep fake videos. You can produce your whole, you know, photorealistic movie in an instant. And the catastrophic events. The problem that one problem I'm wrestling with is that we need regulation, but with regulation comes underground usage. And so, you know, what is the name? I'm forgetting the name of the, Freedom GPT is a tool that was designed by some libertarian-minded engineers, presumably, to be like a free speech GPT with no guardrails. And that might be attractive to some people for some purposes, even for some benign purposes. But it also means that you can go in and type, how do I build a bomb? And it'll just tell you right away. So my worry is that even with regulation, there's still going to be freedom GPT, and there's going to be individual actors that are going to take advantage of that. It sort of redefines, I think, what could be some of your concerns, terrorism and things like that. And I'm not sure what the best solution is. You know, I think, again, this is sort of why we need people with a background in law and policy, and psychologists and ethicists, all working, engineers, all working together to figure out, is there a way that we can, in addition to the regulations, is there a way that we can design the technology and the incentives around it to sort of to minimize these kinds of risks? So part of what I'm doing here is to design a system that you don't need to rely on an honor system. Let's say a regulatory approach is sort of relying on an honor system, that people are going to follow these regulations. And again, we need that, but to the extent that it is limited, we also need good design features that sort of nudge people to use it in responsible ways without even having to think about it. And so that's attractive to me. I don't know that it's a panacea. It's not going to solve all the problems that you raise, but I think there's an opportunity for scientists to go beyond just a list of rules of how we promise we're going to use the technology, into a list of design features that actually help people use it that way.
No, I get it. I mean, sorry, just one feeling I had is there was sometime, I mean, a few years back, there was a movie, I don't know the name, but it was like, I found it very funny, but now I look back at it and I think, oh yeah, it was a movie about humans have built some kind of small moon in the space, and then you have all the poverty on Earth, and there are only selective ones who are living there. They are no longer able to walk or whatever is there in their little cars. They go from here and there. They have this big AI who's doing everything for them. The resources are being mined on Earth, where there is real poverty, there is chaos and everything like that. And now when I think about it, and I said that is already, you have a lot of haves and the have-nots. People are thinking of building superhumans, you know, trying to alter the DNA. I mean, aren't we, you know, more on those lines? Because I'm not saying about myself. I'm saying of a generation which is 2 years old, 5 years old. They won't have any critical thinking because they'll be growing only in this environment where they have seen only this, you know, nothing else. So that is the danger for me, you know.
And I'd love to hear from the audience if anyone else has kind of reactions to this question. Yeah.
Oh, yeah.
Just really quickly, I know I've already asked before, but my reaction to that is I think it's interesting because one of the problems that I was facing or we were facing before in my work was that doctors were wanting to outsource their moral reasoning, or I think one of the things that they were experiencing was because they were having sort of like moral fatigue, and they wanted to do certain things not because they felt it was morally right or et cetera, it's because they didn't want to be sued, or because they were experiencing so much trauma that they were having burnout. And so this is really interesting to me because it brings me the questions like, are people really going to depend on it because it actually helps them alleviate their burnout? And that's like one little small thing that I can think about. It might even be positive, honestly, because burnout really affects your judgment and et cetera, et cetera. So, yeah.
And a question.
I think there's one last comment or question, and then.
Actually, I just wanted to add more so in response, but I like the point of decision fatigue, because I think, especially because I'm also doing a course in this topic of AI ethics, that a lot of the reasons why we're scared of ethics is because it's doing a lot of the decision making unemotionally or like with more of a logical reasoning, which is, I think, interesting because a lot of the issues that we also face are because of emotional interferences and maybe decisions from an unsound mind, or maybe with decision fatigue. And I think just because they are taken by human beings doesn't make them any more like predisposed to being morally or ethically correct, because AIs are also trained by human beings and will have most likely a similar ethical code. And if we weren't so scared of what human beings are capable of, which could be equally catastrophic as some of the outcomes AI could also result in, then yeah, I think the fear, really comes up from an unstable current political and socioeconomic landscape, and introducing AI kind of destabilizes that even further, because it takes this element of control away from generative AI being able to make and take decisions on its own, right? Just to respond. Thank
Sorry.
you.
She raised her hand as well, and then
I have
afterwards
a
we close
question
it.
on a comment, just a bit more conceptual question, not so practical maybe. I'm more on the side of ethics and more out of AIs, and I read an interesting article about creating an agonistic system. So trying to avoid these echo chambers, so like trying to avoid to like create an AI which like kind of brings you out of your own bubble, kind of. So I don't really know if on the technical side, or mathematical side, it's possible, because I know it works on statistical and mathematical calculations, but also like to, also we would love to hear your opinion, or if you, in your studies, you have ever thought about, okay, what if we actually try to exploit these imperfections, like to avoid, for example, an alignment in public opinion or whatever, like creating antagonistic systems, or like exploit these imperfections, or I don't know, what do you think, or if you've ever thought about it?
Yeah, yes, thank you. I know there's some emerging work, for example, by, I think, David Rand, who studies the use of AI for, like LLMs specifically, for debunking conspiracy theories. And they find that, in fact, their method is effective at reducing belief in these unfounded conspiracies, which surprised me that the approach they took was actually kind of a rational approach, trying to use kind of logical argument to change people's minds. As a psychologist, I didn't think this would work, but it actually showed a pretty substantial effect. And so I'd like to see more of that kind of research. These systems, as you know, they're just tools. So they could, like a hammer, they could be used for good or bad. And so, you know, to the extent that we can dream up ways to deploy systems like this that can help on a grand scale people avoid misinformation, to make smarter political decisions, which might just mean make decisions that are more in line with what they actually, with not just the facts, but also what they actually believe, rather than you know, being susceptible to external contextual factors and biases. So the more we can dream up these kinds of use cases, I think that the better off we are at trying to combat the risks that have been raised. Yeah. Thank you. Thanks very much.
Yeah, thank you very much. As we close the event, I would once again like to thank Eyal, our speaker, to accepting the EAI's invitation to come today, and also thanks to all of you for this very lively debate. I think it was great. And I would like to draw your attention to our next speaker series on Wednesday, July 16th, with Patrick Hung. And yeah, be sure to check out our website for more information, and please feel to register. Thanks again.
Thank you. Happy to chat.